Hello, good afternoon. It is still Friday, July 12th. I am still Rob, that developer dad. This morning, we added a way to simulate having a stack of cards, shuffling them, and then picking a card off the top as perhaps a more flexible way of selecting one from N choices. We could use dice, but we're not always guaranteed of having 2, 4, 6, 8, 10, 12, 20, 100 choices. Sometimes we might have 9. Sometimes we might have 36 choices. And we do not have a 9-sided or a 36-sided math rock in our collection. So we added a new component to the dice engine to simulate shuffling a deck of cards and picking the one off the top. Because we have this thought out project structure, we had a place to put it, we were able to implement it, get it tested, and integrate it into the TownsfolkManager fairly quickly. Now, so far, we've been doing sort of manual dependency injection. And that's fine for simple applications, but we sometimes need something a little bit more robust. And yeah, we're smart. We can build something to handle that ourselves. But as individuals and small teams, I don't think we are as smart as all of Microsoft. So we're going to use the dependency injection framework that Microsoft added with .NET Core some time ago. And yes, we're going to add that to a console application. Let's share our screen. Boop. There we go. You got to make the sound effects or it doesn't work. So I created a GitHub issue for it. Let's put it into in progress. All right. And we can make GitHub go away. We've already got Visual Studio Code running. And we see that we still have some changes left over from this morning and that we've got a broken program.cs because it's expecting a new thing to be added. We need to add dice bag. So we could just go ahead and check this in, but I don't like pushing changes to the server when I know there's crashing problems in it. So for now, let's do it this way. And we'll call it dice service. It's a new dice bag. Let's just add it here. Dice bag, dice service, we called it. All right, great. We don't have any problems listed out down here. We're happy. Let's rebuild before we try running it. GM Tools, VS Code, here's that. I need the Explorer for this. Just right click, build. Excuse me. And I believe I've got, how many Finder windows have I got open? Oh, just that one. So let's go into source and the console client bin, debug.net. It's built. Let's execute. Here we go. And we have built ourselves a half-orc commoner. And it says here I can just execute this by typing console client. Let's try that. Control W. Let's get a new window at this location. Shell, new window with same command. No, I don't want to do that. Let's close. Try opening here. New terminal folder. Here we go. And can we do console client? And it says command not found because it's silly. Grr. I'm going to have to look up how to do that because double clicking on this and then just getting a single instance is silly. And that's been bothering me for a couple of days now. I'll Google it later. All right. So we've done that. It's all working. We've got our dice bag. Let's go ahead and push these changes. Added a card shuffler component using that to select a species for our NPC. Tests are passing. Things are good. And let's commit and sync. Okay, there's that. All right, so I wanted to check in my current work now before I start adding what could well be a fairly invasive process. Something else I want to do is reorder these usings. I'm going to move those down here. QRST dice engine needs to go up to the top. There's that. Rule set.definitions, rule set access. I could monkey around with all this stuff until I'm blue in the face, but I at least want to group the related namespaces together. Ideally, I like to have those in alphabetical order, but that's not a huge deal at this stage of the game. So in order to use something a little bit more robust than this manual way of doing things, I think we're going to bring in a package. Now, just before we do that package, there's a test method up in our generator console that I want to get rid of. Let's clean this stuff up a little bit. And let's open this implementation. Here we go. So species data, let's not pull this in explicitly anymore. Let's get rid of that. And we'll get rid of this member level thing. Get rid of that member level thing. And our test species list, let's just get rid of that too. Save it. Okay. We still have test and print. Good. And we can get rid of these things as well. Save it. And out here it's grumping because we're passing in species data. We can get rid of this. This is my favorite way of refactoring, is just deleting stuff that we don't want, that we don't need anymore. So there we go. And I do want to build and run this one more time. Not there. Let's reveal this in the Finder. And I'm going to open a terminal here, and we're just going to do a .NET run, because it'll build for us and then it'll run it. I want to make sure that by tearing all of that stuff out, I didn't remove the mystery bolt that holds the whole thing together. And we're good. We made ourselves a human this time. All right. Let's just shrink that. We'll use it some more in a little bit. So in order to get our dependencies managed by the actual .NET framework, we need to bring in a NuGet package on our console app. Shrink engines down, console client, and I just happened to have looked this up earlier. And I've got it open in another window somewhere. Here we go. I actually found a step-by-step instructions for using dependency injection in dotNet console apps. And it's right here. It's from C# Corner. We have to install a NuGet package using the dotNet CLI, blah, 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 using Visual Studio. And then we start adding stuff down here. We're going to have to do a little bit of refactoring inside the console client thing itself. The first thing we got to do is add this NuGet package. So luckily, the C# dev kit comes with some better automation than just having to drop down to a command line or a terminal and type in and mistype a bunch of commands and so on. So we are looking for Microsoft.Extensions.Dependency Injection. And we want this one. And we want 8.0. Now it should be doing some stuff somewhere. We should be able to see what it did down here maybe. Down here in the ZSH, history restored, nope. Debug, anything? Nope. Output. Loaded by. Doesn't seem to have given us any kind of text output or anything like that. What's this comments thing? Okay, it's just comments in the workspace. I'm not that concerned. Let's bring the terminal back. Now, we can come over here to dependencies and see that we've added the Microsoft.Extensions.DependencyInjection. Next thing we need to do is we need to add our using statement up here. And I like putting Microsoft and .NET stuff before all of the custom usings that come from our solution. I like putting those at the top. So using Microsoft.Extensions.DependencyInjection. And it says it's not used yet, but we're about to change that. So we've got our NuGet package. Let's make sure we build. Build. Here we are. It's building, and it's done. Nothing broke. Good news. So the very first thing we need to do is create our services, and then we can create our app. So here's us creating the app, and we're calling a method on the app. And up here is where we're creating our services. So instead of doing all the code up here in main, I like things tidier than that. Static void create services. And we're going to call it right here. Oh, it doesn't return null. It returns a service provider. So instead of void, we're going to say service provider create services. Now this method's a little angry now because it's not returning anything. We'll fix it. Var services, and let's use a lowercase s for that. equals create services. And then down here, we do one of these. Var service provider equals a new service collection. And we could use fluent stuff and so on, but I think for now, and instead of service provider, I'm going to say, let's rename this to just services. All right. Now, this gives us access to build up a collection of services. Let's return this right away. It doesn't like that at all, because services is an iService collection, and we can't turn a service collection into a service provider automatically. Now, in the background of the dependency injection framework, the service collection is sort of it's a fairly rich class. It's got a lot of capabilities on it, and we can just do this dot build service provider, and that'll return what we're looking for. Let's comment all this stuff out. Just for now. And we've totally broken our constructor for the generator console, because it no longer has a TownsfolkManager to receive. So what do we do here? We need to, theoretically, services.get required service of iTownsfolkManager and provide that to the generator console. Now, if I try to run this right now, we compile, we have 0 identified compiler issues. If I try to run this right now, it's going to blow up in my face, because our services collection or our service provider has no idea what an iTownsfolkManager is and has no idea what service is mapped to that. So let's go ahead and add that down here. Services.add. Now, here's where we start running into some lifetime things. Singleton is something different from transient, and I believe there's an add scoped, there's triad scoped, here's add scoped, add keyed scoped, and all of these things mean different things. For now, let's just talk about scoped versus singleton versus transient in terms of what these things mean. So a singleton, that means that it's going to create exactly one instance of whatever service we are adding to the services collection. And that one instance is going to satisfy every single request that's made for it during the lifetime of our application. Now, in a simple single-threaded application like what we're dealing with here, this console application, we could go ahead and add everything as singletons. Don't do that, because it sits in memory whether you need it or not when you do this. And what happens if I decide to turn this into, say, an API-based solution, and there is exactly one TownsfolkManager that can handle millions of requests coming in from all over the world all at the same time? Well, they're going to end up, the first one's going to go through right away. The next guy is going to have to wait for the first one to finish. And then as we build up, eventually we're going to run out of space to hold the requests, and my users are going to start getting error messages. The lucky ones are going to have to wait for that singleton to process each request one at a time. And I don't want to do that to my users. So there's another thing you can do called add scoped. And what that does is it creates a brand new instance of the service for every request, regardless of how often it comes in. Now, obviously, if you've got millions and millions of requests coming in at a time, you're going to want to introduce some request limiting, maybe some rate limiting or what have you. But for almost every common scenario, add scoped is the way to go. And luckily, Microsoft has been kind enough to add some explanations. So add singleton, we already know that for most cases, the singleton is not the right choice, because we're going to want to be able to have more than one of these things so that we can handle multiple requests at the same time. Add transient basically just it creates a service of the type specified as a transient, and I believe that it only lives as long as it is needed to be active. And I'll look up better definitions of what these different things mean offline, and I'll put something out there with some plain language of what each of them means. For now, we want to add scoped. And scoped just means that the object and its state only lives for as long as the request scope itself. Scope rule set access of type, we want the TownsfolkManager. And yeah, let's say go ahead and use the TownsfolkManager. And that should work. That should be enough. You and I know that it isn't. But let's see what happens when we try to do this. And I'm going to bring this up here because I know we're going to get some error messages. Let's build it. And I really don't like that big ugly function call in there when we're creating our new generator console. Don't care for it at all. We're going to fix that in a little bit. But let's bring up our debugger and let's just try running this. And we're going to get to this line, no problem. No problem at all. Debug, let's hop over here. Yeah. Okay, we're paused. What happens when we try to do that? We're going to get an exception. We got ourselves an invalid operation exception. Occurred in dependency, blah, blah, blah. Unable to resolve service for type rule set access, rule set access. And we get a big, long, bloody call stack here. The good stuff is usually in the first paragraph of this call stack and error message. So this ain't going to run. Let's just let it crash out. And there's our call stack. My goodness, that's monstrous. And it lets us step all the way out through the framework to see what it's trying to do. But the bottom line is it couldn't find an rule set access or an implementation of it. Our service provider has no idea what that is. So I guess we better add one. And we should be able to say services dot add scoped I rule set access, comma, rule set access. Okay. But that's not going to give us our use thing that we had up here. So instead of doing it this way, let's do this a little bit differently. Instead of letting it just build out a rule set access, and this might be perfectly legal, but when we try to call into it, it's not going to have a rule set to access. Let's change this up so that we can explicitly assign the rule set we want to use. So we're going to get rid of this. And we need to provide a function that returns iServiceProvider, or that takes in an iServiceProvider, returns an iRuleSet access, and it's our implementation factory. And this is what builds up what the service provider will give us when we ask it for a rule set access service. So, SP for service provider. Let's do that. And var, nope, didn't like that, because this is going to be multi-line. And let's tidy that up a bit. Make sure it's indented properly. And let's pull that down here. Var rule set access. And let's say I rule set access. And let's say service. Let's just call it service. Equals new rule set access dot use 5ESRD. We'll use that extension method I mentioned earlier. And we need to return our service. So now, whenever I request iRuleSet access, it's going to run this little method, this anonymous function, to build up an instance of our RuleSet access component, tell it to use the 5ESRD, and return it. So let's see if that changed the error message. It's not going to fix everything, because we know the TownsfolkManager also wants a card shuffler, or sorry, a card deck and a dice bag. We'll get to those. But let's make sure that our invalid operation exception is now talking about a different component. So we'll open our debugger, run it. Off it goes. It's building, it's debugging, or it's not debugging, but it's building. It's getting ready to run. It's starting up. And let's step over this, and we get a new exception. And it's unable to resolve service type for type card deck. All right. So we know the score. We know what we got to do. we need to add a card deck. Services dot add scoped iCard deck. And let's just call it a deck simulator, because that's what we called the class that implements it. And let's go ahead and add our dice bag service now, just so that we don't have to go through this, what's the new error message, because we know it's going to want that next too. So there we go. We've got our rule set access. Name could be simplified. Oh, hush. That's fake news. I can simplify that, and then it's going to not know what the heck to do. But our static void main now looks like something a whole lot simpler. Let's run this. And unless there's some detail I haven't implemented yet or haven't gotten to, this should generate us a random NPC, at least with a selected species, and we have another dragonborn. I think the generator believes we're working in Kryn. All right, so we've got our services, all that stuff. It's happy. We're injecting. Now, I really don't particularly care for this at all, because that's a big ugly line of code here. Let's see if our article that I'm working from can add anything to this to make it a little less sucky. Next steps, flexible structure. We're not going to deal with using Entity Framework Core or other NuGet packages or anything like that. Is it still doing the get required service? Yeah, it is. I really don't love that at all. Not even a little bit. But you know what? It'll do. I'm not crazy about it. We're getting our generator console. It's doing that, etc., etc. It resolves all of the required services that we need right here. It's nice and friendly. It's nice and tidy. And we're able to invoke methods on that console component. So good stuff. And we've only altered, what, a couple of files? We've given ourselves a much more robust way of handling dependencies by refactoring one method into two, reorganizing how our dependencies are being created. And the only things we've changed are the project file, the generator console. We changed that to get rid of the extra stuff that we don't need in it anymore. And we changed program.cs. So I'm going to say added framework provided dependency injection to console client. Boop. Let's commit. Sync. Okay. Now, before we move on to the next thing I want to play with, I do want to flip over to the main branch. Close this nonsense. I don't have anything to grab here. So I can switch back to my feature branch. And let's go to GitHub. Here's Safari. And this is number 26. Remember that. Work item 26. In fact, we're going to close out work items 17, 25, and 26. Excuse me. So let's open the root of the repository, or the organization root, in a new tab. Pop over here, load into my GM Tools repository. Here we are. And let's do a compare and pull request. Adding the description here. This will close issues 17, hashtag 25, hashtag 26. Let's go double check that. 17, 25, 26. Cool. Let's create the pull request, assign myself. There are no reviewers, labels, projects. Let's assign this to the GM Tools MVP project. And labels, let's just call it coding. Create the pull request. Off it goes. It is open. Require approval. Yeah, no, I don't have a rule for that. Continuous integration has not been set up. I'm not worried about that. We don't have any branch conflicts. Can we... Let's squash and merge. Hit that. And here's a list of all the things we did in this set of commits. Confirm, squash, merge, off it goes. Let's delete the branch. Goodbye. Take a look at our issues. Actually, let's look at the project and refresh it. For some reason, it didn't close. It closed 25, but not 26 for some crazy reason. Let's just pull these guys over to the done pile. So what do we want to do next? Well, we're choosing a species. The other important things that we need to pick from a list are, come into the TownsfolkManager, and let's keep things high level for now. We've selected our species, and we'll add the details to the species stuff later on. We need to choose a profession and a background. Let's add to-do items for those. Create profession rules, and we're just going to stub it. So I'm going to say stubs of profession rules in the 5e SRD set. Select a profession in the TownsfolkManager. Boom. And then we also want to create stub of backgrounds in the 5e SRD rule set. Select a background in the TownsfolkManager. Save. Whoops. That's going to try and save the web page. Ha! We hit enter to save. This guy will convert it to an issue. Boop. In the GM tools, I'll assign myself our label. This is just pure development. Because we've already done the architecture, we already have an idea of how we're going to do this because we've established our pattern. And let's edit this. Follow the pattern we established for setting up species options. And I'm going to copy this comment. I'm going to save it. Close this one. And we're going to pull it over here. I'm going to convert this to an issue. Bonk. On the GM tools repository and project. Assign me pure development. Edit this. Same description. Save. Off it goes. And let's go back to VS Code. Now, I don't want to keep working on this create TownsfolkManager artifacts branch because I did delete it when I was up in GitHub. And you can see when it first flipped over here to the main branch that everything's broken because I haven't pulled down the code in the main branch now that it's changed to include all of the stuff that we did before. Let's do a preemptive strike and build it. And it's built. Let's see about running that console app, and that's not in the documentation folder. Console client, bin, debug, and let's just hit that guy real quick. And we have ourselves a human NPC. All right. First thing we're going to do is create a new branch. New branch name, feature, add, profession, and no, let's just add profession. Add profession stubs. Okay. First thing we got to do is make sure our rule set access and our rule sets know what the heck a profession is. So we've got our contracts, rule set access, load character creation rules. Okay, so that guy lives over in our definitions. So we can collapse this. I don't think we have anything to change over here in the rule set access. No, we don't. So rule set access is pretty stable. We better come over to definitions. Take a look at our characters, and here's our character creation rules. And we've got species rules. Let's get rid of that. Excuse me. And So if we're going to choose a background template, we're going to need background data. And remember, we're still in our abstractions library here. So we've got species data and species template. So what that tells me is we're going to need a new class, a couple of them. It's going to be a class, and let's call it background template. And we're going to need another class called background data. Needs to be a class called background data. All right. And all of these templates at the beginning of their lives are going to look really, really similar. So our template represents a specific definition, or rather, our background template represents what a background looks like. And we see that right now, all it's got is a name. So I'm going to pull this off to my other monitor briefly, just while I flesh out this background template. So let's bring this up here. All backgrounds have a name, and it is a property. That is a string. And I'm just using plain vanilla name with get and init. Now, when we're using initialization constructors or initialization properties, that means we might be deserializing this particular thing or instances of this class from, say, JSON or what have you. And JSON serializers all require a parameterless or empty constructor. So here's name equals string.empty. If we don't specify that, it's going to get grumpy at us because a string is a reference type, and the default behavior that the compiler wants to see, just to keep ourselves from hurting ourselves later, it wants to see anything that is not explicitly marked as nullable. It wants to see those properties have a value when we exit the constructor. And that's really just a solid programming concept where when we construct an instance of a class, we want that instance to already be in a valid state as soon as we're done constructing it. So what we call new background template, whatever gets assigned to the variable that we're assigning to with that constructor call, that variable's ready to go. It might not have any useful data in it, but as far as the state of the object is concerned, it's valid. And that's all we need right now for background template. So we can save this and we can close it. Now, what does species data look like? It's a little bit more complex. And this is an iGame options set. And it's also an abstract class. Species template is not abstract, and perhaps it should be, but nah, let's not mess with it. So now for background data, and I'm going to pull species data off to my other monitor just so that I have it up in front of my face for reference purposes, because we're going to use the exact same pattern here. Background data. We're going to make this into an abstract class. But our abstract class and all child instances of our background data base class must give us some guaranteed behaviors. And it's an iGame option set of background template. Now, I'm using the word iGame option set here. But you could consider background data. All it is an organized collection of individual instances of some specific type. Now, what if we think about our background template as the schema of a database table? And our species template is the schema of our species table. Species data now represents the species table and all of the rows inside of it. Each row is an instance of species template. And each row in our background data is an instance of background template. And this iGame option set, if we were using Entity Framework over some database, this would become an IDB set. And our background template would represent the dotNet CLR representation of the table that we're abstracting into code. But that's a whole lot of heavy stuff, and we're not dealing with Entity Framework or databases. So we're just going to keep using these concepts rather than mess up our heads and have to deal with all of that type of thinking. So we've just created a backing store in memory to hold our collection of all these background templates. We need a constructor for our background data, and it is going to be that. We're just instantiating a brand new list. We need a protected abstract void initialize templates, because that's how our concrete versions of the background data classes are going to populate that list. So let's see what's over here. Oh yeah, we're going to need a protected void register background, and it's going to take in a background template. And this one, we can go ahead and implement it right away. Background templates.add background. And then, of course, we need to protected abstract void initialize templates. And that's the method that is going to be unique to each kind of background data class that actually gets used. This is what we're going to call inside those classes to register the backgrounds for the specific rule set that we're using. Now, down here, list, we're going to do almost exactly the same thing here as we did over in our species. As a matter of fact, let's pull species data over here, hide my explorer, hide my change graph. Let's split this guy off to the right. So the list method over for species all it does is it creates an array representation of the names in the species list, or in the species templates list. Over here, we're going to say var background list equals from background templates. The only thing we want to return is the name of the background, b.name, and we want to convert that to an array. And then, of course, we return that background list. And then background template load, easy peasy. Var ret, and I just use ret as the short form of return value. We're going to reach into our background templates collection, get the first background whose name matches the option name that we pass in, or null, and return the result of that link query. So there's background data. Sweet. Before we go into actually creating some 5e backgrounds, let's make sure we can access our background data. So, background data, background rules, get. We got that. And provides access to the backgrounds that are available in the implemented rule set. And let's send that away. We'll keep the vocations for later. Now we've got our character creation rules. This is just the interface. So that's just the description of what a component should look like. Is it going to let us build everything in here? No, it's not. So let's build our solution. And because we've just changed a contract, we're going to need to adjust the implementation of that contract. And luckily, the compiler is going to cuss us out as soon as it discovers that there is a party to this contract that is not in compliance. And we see character creation rules does not implement interface member boogity boo in RD&D 5 ESRD. So let's go here. And we see that we've got character creation rules right here. There's the species data. Let's implement this interface. Boop. And this is throwing a new not implemented exception. I don't love lambda bodied properties in every case. So I'm going to do this as a more explicitly declared get property. And we're going to return background data. Well, background data doesn't exist, so I guess we better declare it. Private read-only background data. Well, that's not going to do us any good because we can't create a new background data because it's abstract. So we need a concrete background data type. Well, that's not anything we haven't done before. So that's outside of our definitions. Let's go into 5e SRD and create and add a new file. It's just going to be a class. And let's call it backgrounds 5e. And I named the species provider, and that's a bit of a misnomer. So I'm going to call this backgrounds 5e data. There's that. Our species, it inherits from species data and does some stuff. So just for speed, because we are coming up on, or we are past 2 o'clock, 5e, it's going to inherit from background data. Great. And background data has some required stuff on it. I don't need to generate the constructor, but I oughta. And I need to chain over to the base class constructor to make sure that the list of backgrounds exists. Let's take another look at species 5e provider. We need to call initialize templates, and then inside initialize templates, we just create new template instances and register them with the base class. Pulling that over here, and 5e data, we need to implement our abstract methods. There's that. Initialize templates, I believe, should get called in the base class constructor. It doesn't. But you know what? To save ourselves the agony of forgetting to call initialize templates, I'm going to move initialize templates over to the base class constructor on our species data and background data. There's characters, background data, initialize templates. There's that. Let's do the same thing over on species data. We've created our list. Let's initialize the templates here. Species, background data. We're going to keep backgrounds 5e open. We're just going to do this. Send that away. Character creation rules. We are in the 5e rule set. Backgrounds 5e data. Could not be found. Probably because I have to save the file. Come back over here. Is it in a funny place? 5e SRD. I don't know why it's being silly. Let's try building this. Rule set definitions. Let's try building this guy. Here we are. And it's building. Da 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 da. All pro. And we got exit code 1. We still have a problem. Backgrounds 5e data. Backgrounds 5e data. It's public. copy that. Oops. That's not what I wanted. Character creation rules. This is in 5e SRD. Hide the definitions, character creation rules. Grab the name of this class one more time. Copy. I don't know why it was kicking up such a stink, but I think we good here. We're now valid. Our background data is empty. It hasn't got a darn thing in it. So let's just go ahead and add a couple here. Oh, and if I try to run this right now, it's going to throw up all over the place. So I'm going to run a little longer than an hour I already have, but we're going to run just a couple more minutes past because I want to get at least a couple of these backgrounds integrated in my data class. I initialize backgrounds using the following pattern. Okay, so what I'm going to do is going to be super lazy. And let's take a look at our species 5e. And I'm going to shrink this up so that it takes up a little less vertical space. And I'm going to use ChatGPT. So down here, or over here the other day when I was setting up the species lists, I asked it to just create a list of C# comments listing out the names of the species. What I want to do here is say this. Background template. Background name. Template equals new background template. Background. And I'm going to change this replacement token in here to just background. Register background. Grab this. Using the following pattern in C#. Please extract the list of character backgrounds from the D&D 5e SRD. And output that pattern for each background. Use the word background in square braces as the replacement target. And let's see what ChatGPT does for me as far as just generating code to spec. Will you look at that? Well, that's lovely. I quite like how it did that. And this is almost exactly right. But good stuff. Since the individual template variables are method scoped, can you redo what you just did, but name those instance vars using camel case? Oh, yes. Oh, yes. That's going to save me many minutes. Copy the code. Here's a species 5e provider. Hey, Chandu, it's going okay, man. I am cheating like a son of a gun by importing the D&D 5e SRD document, the systems reference document, the one that Wizards released under the Creative Commons license. I imported that to ChatGPT, gave it a template for some repetitive code that I need to write, and asked it to look up all of the different backgrounds that are available in the 5e rule set and create those as template objects for my 5e rule set component. Now that we've got that and all the other things that we need, let's come out to our TownsfolkManager. Now we want to select, get the list of species we can choose from, pick one of those, assign it to the species property. Let's bounce down to backgrounds. So, step one, get the list of backgrounds, pick one at random, assign its name to the background name property on our NPC instance. First thing we need, list of backgrounds. NPC rules is our rule set access. So background choices equals npc rules.background rules.list. Pick one at random. Var npc background equals, not the dice bag, but we want to use our shuffler service. Pick one of these background choices. And we are going to assign npc dot background dot name equals npc background. Save it. I want to make sure I didn't do something silly like make name read only on that, and I did not. Good. Let's build. And we're building. And it's doing all the things super slow. I don't have any problems alerted up here. And it says it's done. I should have a Finder window open to the right place. I don't. Okay, GM tools, source, console, bin, debug, run it. We have an NPC who is an elf with the acolyte background. They grew up in a monastery or a church or some sort of religious order. Fantastic. Okay, and I see this. I wonder if I can copy that. Bring it over here. Just before I go, I want to, no, I'm not gonna. Okay, so we've run it. We have an elf. We have selected a random background. I want to run it again. Do it again. We've got a dwarf folk hero. And we could run it again and get something completely different. Here's a half-orc urchin. Things are moving right along. And hey, thanks for the follow, Chandu. And so we're slowly making progress, but we didn't have backgrounds getting chosen randomly when this time yesterday. We didn't have species getting chosen randomly this time yesterday. But because of all the planning and proper componentization that we've done and all the testing and all of that stuff, we spent most of yesterday establishing the patterns that we introduce or that we use when we're building out our rule sets. Patterns, schemas, all of that stuff. Tech books that I like, yes, there are a few. Probably the most important tech book I have ever read is called Writing Software by Yuval Lowy. I'll put the name of that in the chat. And let's see here. Send a message. Come on, wake up. I'm not necessarily building it for a video game. I'm building this because I run a homebrewed Dungeons and Dragons game and I make up the whole world and all of the characters in it and everything like that. And my players are always asking me, so this blacksmith, who is he? What does he look like? Is he tall? Is he short? All of these things. And I'm really bad at coming up with that stuff like right in the moment. So I want a console application or maybe like just a little web app that I host on my laptop that I bring to game so that when they run into somebody new, I can say, oh, I need a new NPC, push the button, and I get back what or a description of who they're about to encounter. So the name of the book is Writing Software by Yuval Lowy. Oh, Dungeons and Dragons? Oh, it's a lot of fun. It's just you know, if you've seen Stranger Things, it's that. So here we go. We've got our background. We've at least got our list of backgrounds. It's integrated. It's selecting. I am going to go ahead and added backgrounds as a data source to our rule sets. Implemented for 5E SRD with a little help from ChatGPT. And this will close GitHub issue. I thought I was going to do professions, but I did backgrounds. It's issue number 29 that we're going to close. GitHub issue number, did I say 29? Yes, 29. 29, commit. And because this work that we just did in the past 50-ish minutes closes out that GitHub issue, it's not profession stubs. Can I rename this branch? No, I can't. Heck with it. I'm going to publish it, and I'll just add a comment when I do the pull request. So that's up there. Let's go back to GitHub real quick. Go over here, code, branches. Let's do a compare and pull request. Added backgrounds. Yes, I know the branch is called professions. I did backgrounds instead. Professions will come later. Next. Bonk. GitHub issue that. I'll assign myself. Add it to the GM tools. MVP project. Use closing keywords in the description. What are some of these closing keywords? About linked issues and pull requests, changing. So you can link a pull request to an issue by using a supported keyword. Okay, neat. And I'm going to say closes number 29. Here we go. We're able to merge, squash and merge, confirm squash and merge. And let's delete that branch. Back out to Visual Studio Code, bounce to main. And can we fetch? Here we go. It's fetching. And I want to pull those changes down into the main branch so that on Monday or later on today, when I pick up the professions list and add that, because I'm just going to do that offline, because it's the same pattern that we use for species and backgrounds. I'm going to use the exact same technique for our professions. There's no need for me to do that in a live stream. I'll just add it offline. On Monday, we're going to start adding some details to probably the species and see how that impacts the other properties in our NPC generator. So until then, it is the weekend. I've got some chores to do about these videos, get them posted up on the social media things and all that stuff. But after that, I think I'm going to go chill for a little while. I'll add the professions in later today or over the weekend. But it is the weekend. Be safe, have fun, take care of yourselves, and try and relax and do something other than play with code for the weekend. Go outside, touch some grass, drink some water, stuff like that. Take care.